What's up, everybody? I'm doing this off of my phone, so hopefully it's not too bad. But I know I've been absent a lot, and I'm gone today again, and wanted to make sure that y'all had a chance to go through these notes. And so, reflecting back on 7-1 that we did Pythagorean theorem, you probably had a good foundation coming into my class. Your teachers in the past have done a good job to teach you that a squared plus b squared equals c squared. That's our Pythagorean theorem. And here in this geometry class, we're going to also look at it as c squared equals a squared plus b squared. And this doesn't change the Pythagorean theorem. It's the exact same thing. We get the same results. All we're doing is flipping the order of where we're putting the hypotenuse within our formula, within that set. So you can see on your notes right there, we're going to look at it this way. It helps us whenever we get on the second page. Okay, shortcuts. Everybody likes that word. We're going to look at several shortcuts today. The biggest shortcut that we got is to look at Pythagorean triples. Okay, what is a triple? This means that we're going to take our Pythagorean theorem, and anytime we get whole numbers as our answer for all three sides, it's a triple. So for instance, if we have a triangle 3, 4, and we did the Pythagorean theorem, we would find out the hypotenuse is 5. This is a triple because all three of these are whole numbers. This is our first one that we're going to look at, 3, 4, 5. I actually elaborate a little more on this because I want you to recognize this. We see it so often, and it is the only one that goes in order numerically, 3, 4, 5. So I call this the perfect Pythagorean triple. Other triples that we have, 5, 12, 13, and 8, 15, 17. And then last, 7, 24, and 25. Okay, now how do we use these? These are nice. You're telling me they're shortcuts, but how do we use them? Okay, this is how. We take an example that we could have here, and let's say it's a triangle. And one side's 4, and the hypotenuse is 5. We know from our triples that we can know that, hey, if one of the legs is 4, the hypotenuse is 5, the other leg has to be 3. We're more or less just taking a jump and not doing the Pythagorean theorem all the way out. We should set this problem up as 5 squared equals 4 squared plus x squared. Then 25 equals 16 plus x squared. Then subtract 16 from both sides and get 9 equals x squared. And then take the square root and get 3. So this is a shortcut. If we recognize this, we can just jump to our conclusion really fast. Okay. Now, you're going to see variations of the 3, 4, 5. You're going to see triangles that might be like this, and they want you to solve for x. Once again, you could still go and do the Pythagorean theorem. And solve. Or you can recognize the 3, 4, 5 out of this. This is the perfect Pythagorean theorem because 3 times 5 is 15, and 5 times 5 is 25. This is a 3, 4, 5 Pythagorean theorem, except it's a multiple of 5. It's 5 times bigger than what the original one, the 3, 4, 5 would be. So for x, we just need to think of it as 4 times 5, which is 20. This allows us to do problems a lot faster than actually working out the Pythagorean theorem all the way. Now, that doesn't always work out because you might not recognize it, and it is okay. Just do the Pythagorean theorem, and you'll be good to go to continue on. So that is our Pythagorean triples. And then here in the next video, we will attack this next section. On this next one right here, recall that given three sides, a triangle can be formed only if the sum of the smaller two must be greater than the third. So if we were looking at this and C being the biggest side, A plus B has to be bigger than C. We did this back in, I think, chapter 3 or chapter 4. Looking at this example right here, we have 3 links. C is always the biggest. So this would be your A and your B. Add the 2 smaller together, 4 plus 5. That has to add up to be bigger than the longest side, C. Well, 4 plus 5 is 9, and 9 is bigger than 6. This would make a triangle. On this one, 4 and 5 are the smaller 2. That adds up to 9. Is 9 greater than 9? No, they're equal. This would not make a triangle. 4 plus 5 is 9. Is 9 greater than 10? No, this would not make a triangle. When we did this last time, we talked about classifying triangles. If we were to classify this, this has 3 sides that are not the same. We would call that scalene. However, using the Pythagorean theorem, we can actually classify triangles by their angles, not just their sides. So that's what we're going to do. We're going to test it out first. Does it make a triangle? If yes, classify it by the angles. As we look on the next page, we can kind of recap on when we're classifying by angles. We're going to look at acute angles, obtuse triangles, and right triangles. If a triangle can be formed, that's the first thing you got to do. Can a triangle be formed? And if it can, then we will make, if it can be formed, then we will classify it. I'm going to change out my papers here since the first one bled through. All right. Now, off of this, we need to know what's going to go in here. So on every one of these, if you notice, they're set up like the Pythagorean theorem. Let's put a little box right here. I call this the comparison box. Okay. And once we start classifying, whatever's in that box is going to tell us what type of triangle this is. If it's a right triangle in the box, we'll have an equal sign. If it's an acute triangle in the box, we'll have a less than sign. I always think of it as like a little, acute little triangle. Obtuse, greater than sign. We're talking about something big, so it's going to be obtuse. Okay? Remember, the very first thing, is it a triangle? So right here, 5, 12, and 4. The smaller 2 sides would be 5 plus 4. Is that bigger than 12? 5 plus 4 is 9. Is 9 greater than 12? No. This will not make a triangle. Do not classify it. You have to test to see if it makes a triangle first. On the next one, smallest sides, 6 and 7. Adding those together, we get 13. Is 13 greater than 8? Yeah, it is. This makes a triangle. Now we can move to step 2. Use the Pythagorean theorem and determine what type of triangle it is. Pythagorean theorem, c squared, comparison box, don't put the equal sign yet, a squared plus b squared. C is 8. Comparison box, A is 6 and B is 7. If I go and square these, that's going to be 64 compared to 36 plus 49. Adding these together, I get 64 compared to 85. What goes in the box? Greater than, oops, sorry, I messed that up. Less than 85. Less than 85. So if it's less, it's an acute triangle. Okay, step 1, is it a triangle? Step 2, use the Pythagorean theorem to classify it as a triangle. Okay, off this next piece here, the square root of 10 might throw you for a loop. If you were to type it in your calculator, you would get that as 3.16. Okay, obviously, it is a little bit bigger than 3. That would be the C. 1 plus 3 is 4. Is 4 bigger than 3.16? Yes. This makes a triangle. Classify it now. we're going to look at it as the square root of 10 squared compared to 1 squared plus 3 squared. Anytime we square a square root, it just cancels the operation. 10 compared, 1 squared is 1, 3 squared is 9. What goes in the box? Hopefully, you're thinking like I am, an equals. And if it's an equal, then it is a right triangle. On this next one, it can get a little tricky right here with it being the square root of 27. I know that that's the biggest, okay? But if I look at it and try to compare it, I need to add these two together. Well, the square root of 9 is 3, and the square root of 16 is 4. Is that bigger than the square root of 27? I don't actually have a calculator with me, but if I add these together, I get 7. Now, I'm going to kind of think about this, that 25 squared is 5. I'm sorry, I said that wrong. 5 squared is 25, and 6 squared is 36. This is right between those two. So this answer is going to be 5 point something. I don't have a calculator. I'm not doing it in my head. So this is bigger. 7 is bigger than 5 point whatever decimal. So now, classify it. 27 squared compared to the square root of 9 squared plus the square root of 16 squared. Works out nice and neat on this one because all the square roots are canceled out with the squares, and we get 27 compared to 25. 27 is bigger. That is a greater than. This is obtuse. Okay, that is our Pythagorean triples. That is our how we classify angles, or I'm sorry, how we classify triangles using the Pythagorean theorem.